Okay, so let's talk about second order reactions. Um, so again, we're assuming that we're starting off with one reactant to form a product or products. And if this is a second order reaction, then this would be the rate law for that reaction. Rate is equal to K times the concentration of A raised to the second power. All right. So we can rearrange this to get this expression. And in doing that, we can determine what the units for K would be. So the unit for rate is m over s. The unit for A squared, concentration of A squared would be m squared. And this simplifies to 1 over m times s. So that would be the unit of K. Of course, again, as far as the time part is concerned, that could be hours, that could be minute, and so on. So setting this being equal to this will give you this expression. And when you integrate this, which means that you need to do some calculus, you're going to end up with this relationship which relates the concentration of A to time. And you'll notice that this equation is in the form of y is equal to mx plus c. Let me just do my, right? So 1 over A would be the y term. 1 over initial A would be the c term. K would be the m, and t would be the x, which means that if you plot y versus x, or 1 over the concentration of A versus t, you are going to get this straight line plot with a positive slope, and that positive slope would be the K, and where it cuts the x-axis, I'm sorry, the y-axis, that would be 1 over the initial concentration of A, all right? Now, going back to the half-life concept, remember half-life is a time when half of the initial amount of the substance reactant remains. So therefore, if you plug in half-life where T is and A0 over 2 where this is, then you're going to end up with this relationship where the half-life is equal to 1 over K times the initial concentration of A, all right? So that's basically what happens in the case of a second order reaction, the relationship between the concentration and the time. So this here summarizes all that we have discussed with respect to the different types of reactions: zero order, first order, and the second order. All right, so these are equations which relates the concentration to time in each case. And here are the corresponding half-life expressions, all right? So this is something that you basically need to know how to use and apply to solve certain problems involving these different types of reactions. Okay, so that's it for now. What I'm going to do in the next couple of videos is do examples of problems involving zero, first, and second order reactions. All right? Okay, until next time.